Hello and welcome to Mrunal's Math Tutorials, and in today's tutorial we are going to look at normal distribution. I'm going to go over some difficult questions which you might have in your AS examination. Alright, so before we begin the tutorial, if you haven't subscribed to my channel, make sure you like and subscribe the channel because it motivates me to create more videos for you. Alright, so let us begin. Question number 1. The lengths in centimeters of leaves of a particular type are modeled by the distribution n 5.2, 1.5 square. That means the mean is 5.2 and the variance is 1.5 square. Find the probability that a randomly chosen leaf of this type has a length which is less than 6 centimeters. So we need to find the probability that the length of the leaf is less than 6 centimeters. So first step is to standardize by using the formula z is equal to x minus mean over standard deviation. So probability would be z score would be less than x over here. In this case your x is 6, yeah, the mean is 5.2 and the standard deviation is 1.5. So let's substitute that. So it's going to be 6 minus 5.2 divided by 1.5. So you get the z score to be 0.533. Remember, the z score has to be always 3 decimal places. So look up in your table for a z less than 0.533. So that is going to be 0.7029, which can be approximated to 0.703. Part B. The lengths of the leaves of another type are also modeled by normal distribution. A scientist measures the lengths of random sample of 500 leaves of this type and he finds out that 46 are less than 3 centimeters long and 95 are more than 8 centimeters long. So we know that over here that we have probability of the length of the leaves to be less than 3 centimeters is going to be 46 out of 500, which works out to be 0.092. And we also know that the probability of the length being greater than 8 is 95 out of 500, which is equal to 0.19. So again, let us standardize. So z score would be, the length over here is now 3. So 3 minus mean over standard deviation. We have not been given the mean and standard deviation. In fact, we need to calculate the mean and standard deviation of the lengths of this type of leaf, right? So this is going to be then equal to 0.092. All right. So you notice that we are calculating a probability which is less than, and this value is also less than. So when we have less than and less than, the z score is going to be negative. So 3 minus mean over standard deviation is going to be negative phi inverse of 0.092. Again, you got to remember that we cannot calculate phi inverse of 0.092. So you have to do it 1 minus. So that's going to be negative phi inverse of 1 minus 0.092. So that is going to be negative 1.329. So it means that 3 minus mu over sigma is equal to negative 1.39. Likewise, let us calculate what do we have over here. We have over here probability of z square greater than 8 minus mean over sigma is equal to 0.19. So when over here we are having greater than and less than. So when I say less than, I mean over here less than 0.5. Okay. So when we have greater than and less than, the z score is going to be positive. So 8 minus mean over standard deviation is going to be then phi inverse of 1 minus 0.19, because you cannot calculate the phi inverse of any value which is less than 0.5. Yeah, so we do 1 minus 0.019, so that gives me 8 minus mean over sigma is going to be 0.878, or I can say that 8 is equal to mean plus 0.878 sigma. And here also I can say that it is going to be mean plus, or rather it would be mean minus 1.329 sigma. So we now need to solve these two equations simultaneously. So let us do that. So we have 3 equal to mean minus 1.329 sigma, and we have 8 equal to mean plus 0.878 sigma. We subtract, we get 3 minus 8 is negative 5 minus 2.207 sigma. So sigma is going to be minus 5 divided by minus 2.207, which is equal to 2.27. Substitute this value in any one equation, either in this one or in this one, to calculate the mean. The mean is 6.01. All right, that was part B. Part C. In a random sample of 2000 leaves of this second type, how many would the scientists expect to find with lengths more than one standard deviation from the mean? Now, more than one standard deviation from the mean, what does that mean? It means that if you're having mean over here, how many are more than one standard deviation from the mean, and how many are, when they say more than one standard deviation, we are looking at onto both the sides. Yeah, so we are looking at over here and over here. So the lengths, the probability of lengths, which is less than mean minus sigma, and probability of length which is greater than mean plus sigma. You have to remember over here it says that how many would the scientists expect to find with lengths more than one standard deviation. Yeah, more than one standard deviation you need to take into account on both the sides, on the left and onto the right. So this is your x value. This is basically your x minus mean, in that x is this. So if you substitute one of them, I'm just going to show you. So mean minus sigma minus mean over sigma, this is going to give you negative 1. Yeah, so probability of z-score is going to be negative 1. That's your z-score. And on this side, if you substitute, it's going to be again the formula x minus mean over standard deviation. Your x is mean plus sigma minus mean over sigma. That gives you probability of z-score greater than positive 1. Yeah, how do we calculate probability less than negative 1? It is 1 minus probability of z-score less than positive 1. Yeah, so that is going to be 1 minus phi of 1, and here you're going to get 1 minus again probability of z-score less than 1, which is 1 minus phi of 1. So basically if you add these two, you're going to get 1 minus phi of 1 plus 1 minus phi of 1, that is 2 minus 2 times phi of 1. So which is 2 minus 2 times phi of 1 is 0.8413. This works out to be 0.3174. Remember, the question is asking us the probability. So we have 2000 leaves. Yeah, so the number of leaves would be 2000 multiplied by 0.3174, which is 630. 35 leaves approximately. Yeah, so the scientists may find 635 leaves if they select a random sample of 2000 leaves. All right, so that's about this question. Let's move on to the next one. In a large population, the symbolic in a large population, systolic blood pressure SBP, excuse me if I didn't pronounce it correctly, of adults is normally distributed with mean 125.4 and standard deviation 18.6. Find the probability that SBP of a randomly chosen adult is less than 132. So again, let us standardize it. So less than 132 minus the mean 125.4 divided by standard deviation, which is 18.6. So this works out to be, use your calculators for that. This is going to be then less than 0.355. Remember, z-score has to be given to 3 decimal places. This works out to be 0.6387, which you can round it off to 0.639. You must round your answers to 3 significant figures at the end. Yeah. Let's look at the part B. The SPP of a 12-year-old child in the same population is normally distributed with mean of 117. Of these, 88% have SPP more than 108. Find the standard deviation of this distribution. So we know that probability of x greater than 108 is 0.88. So here we are having greater than and greater than. So this value is also greater than 0.5. So when we have greater than and greater than, the z-score is going to be positive or negative. You got to tell me, what is the z-score going to be, positive or negative? If you have greater than and greater than, the z-score should be negative. So probability of z-score greater than 108 minus 117 over sigma is going to be equal to 0.88. And as I said earlier, when we have greater than and the probability is greater than 0.5, the z-score is going to be negative. So we say that this is going to be then equal to negative phi inverse of 0.88. This works out to be 9, negative 9 over sigma, and the phi inverse is 1.175. Remember, when you look up in the table, you need to look up for the probability 0.88. Yeah. So this gives me, so search for the probability 0.88, not the z-score, right? So that's going to give me negative 9 equal to negative 1.175 sigma, or sigma is going to be 9 over 1.175, which is 7.66. So sigma is approximately equal to 7.66. All right, that's about this question. If you haven't subscribed to my channel yet, make sure that you hit the like button. Let's go on to part C. 3 adults are chosen at random from this population. Find the probability that each of these 3 adults have SBP within 1.5 standard deviation of the mean. So that means you have mean in the center, and here you have mean plus 1.5 standard deviations of the mean, and here you have mean minus 1.5 standard deviations of the mean. Yeah. So we are looking for a probability which is between them, because it says within, right? So if you try to work out what will be your z-score, your z-score is x minus mean over standard deviation. So it's going to be mean minus 1.5 sigma minus mean over sigma. So it's either going to be, as you can see, it is going to be negative 1.5, yeah, or it is going to be positive 1.5, right? So basically we are looking for negative 1.5 less than the z-score being positive 1.5. Remember, as a rule of thumb, when we are looking for probability from minus a to a, within that it is same as 2 times probability of z-score less than a. So when we're looking for within minus a and a, the probability is 2 times probability less than a minus 1. So using that, we could say that the probability is going to be 2 times z-score less than 1 minus 1, which is phi of 2 times phi of 1 minus 1, that is 2 times, oh, and sorry, this is going to be 1.5, not 1, 1.5. Apologies for that. So that's going to be 0.9332 minus 1, which is 0.8664. And then the probability, since we are calculating probability that each of these 3 adults, so for one adult it is 0.8664, each of these 3 adults means the probability would be, for the first one 0.8664, for the second one 0.8664, and for the third one is the same. So I can say that it is to the power of 3, which is 0.650 approximately. All right, that's about this question. Let's move on to the next one. Question 3. The lengths of particular type of a tree are modeled by normal distribution. A scientist measures the lengths of a random sample of 500 leaves from this type of tree and finds out that 42 are less than 4 centimeters long and 100 are more than 10 centimeters long. Find the estimates for mean and standard deviation of the lengths of leaf from this type of tree. So again, this question is similar to question number 1. You may want to pause the video and try it by yourself and then compare the answer with me. So we know that probability of x less than 4 is 42 out of 500, and probability of x greater than 10 is 100 out of 500. Yeah, so we could say that, which is this calculates to 0.084 and this is 0.2. So then we can say that probability of z-score, and now we have x is 4, so 4 minus the mean or standard deviation is equal to 0.084. Again, if you look, less than and less than, so whenever we have less than and less than 0.5, the probability, the z-score is going to be negative. So when is the z-score negative? When we're calculating probability of less than and the given probability is also less than 0.5, or if it is greater than and greater, the probability is greater than 0.5, greater than or less than, the z-score is always negative. So we have 4 minus mean over sigma is going to be negative phi inverse of course, you cannot calculate phi inverse of 0.084. It doesn't exist in the table. So going to do 1 minus 0.084. Yeah. Remember, the sign of phi inverse depends on this one. Yeah, don't get confused, because if you forget to look at it at this step and you when you do 1 minus you get a number which is positive, you'll be confused. Yeah, so look at that step to decide the sign. So this is going to be negative 1.379 because this is going to be 0.916. Yeah. So we can set up an equation. 4 minus mean is negative 1.379 sigma. Likewise, let us calculate for this one as well. So probability of z-score greater than 10 minus mean over sigma is equal to 0.2. So here we are having greater than and less than. So z-score is going to be positive. So it is phi inverse of 0.2, which you cannot calculate. So you do 1 minus 0.2. So 10 minus mean over sigma is going to be 0.842, because that turns out to be 0.8. And then your equation after cross multiplication is going to be 0.842 sigma. Now you need to solve these two equations simultaneously. So let us do that. So I just rewrite it as 4 equal to mean minus 1.379 sigma and 10 equal to mean plus 0.842 sigma, and I subtract these two equations. That is going to give me minus 6. This gets cancelled. Minus 2.221 sigma. Sigma is going to be 6 divided by 2.221, which is 2.70. So sigma is 2.70. Substitute this value in any one equation, either in this one or in this one, to work out what is the value of mean. It works out to be, I'm just going to do that quickly. So mean is going to be 7.72. All right, that's about this question. Let's look at the next question. Oh, it does have a part B. All right. The lengths in centimeters of the leaves of different type of tree have normal distribution, mu and sigma square. The scientist takes a random sample of 800 leaves from this type of tree. How many of these leaves the scientist would expect to have lengths between mean minus 2 standard deviation and mean plus 2 standard deviation? So again, we have mean minus 2 standard deviation and mean plus 2 standard deviation. So if I just calculate the z-score, it's going to be mean minus 2 standard deviation. That's your x minus the mean over standard deviation. That is going to give me the z-score to be negative 2. So obviously the other one is going to be positive 2. So we are looking at negative 2 between the negative 2 and positive 2. So it's going to be 2 times probability of z-score less than 2 minus 1, or 2 times phi of 2 minus 1. This works out to be 2 times 0.9772 minus 1. That gives you 0.9554. And we could then say that there are 800 leaves. So 800 leaves, and the probability of picking between mu minus 2 standard deviation, mu plus standard deviation is this. So you multiply the number of leaves by the probability. Don't forget that step. So this works out to be 763.52. which is approximately 764 leaves. Okay. Let us look at the last question again. If you haven't subscribed to the channel, make sure that you hit the subscribe button. It just really motivates me to create more informative videos like this, which are easy to understand, and I'm hoping that all of you will understand this concept very well. Okay, the lengths in centimeters of middle fingers of women in Rhineland have a normal distribution with mean mu and standard deviation sigma. It is found that 25% of these women have fingers longer than 8.8 centimeters, and 17.5% have fingers shorter than 7.7 centimeters. So what do we have? We have the lengths of the finger which are greater than 8.8 centimeters. So we have the probability of that is 0.25, and probability of lengths less than 7.7 is equal to 0.175. Yeah, let us standardize this now. Z-score greater than 8.8 minus mean over sigma is equal to 0.25. And here we have z-score less than 7.7 minus mean over sigma is equal to 0.175. So on this side, we have greater than and less than. That means z-score is going to be positive. So 8.8 minus mean over sigma is going to be phi inverse of 0.25, which you cannot calculate. So you have to do 1 minus. So if you do 1 minus 0.25 is going to give you 0.75, and we can see that this is going to be then 0.674, and first equation is going to be mean plus 0.674 sigma. All right, that's your first equation. Let's work out the equations for this side. So you're having less than and less than. So the z-score has to be negative. Okay. So 7.7 minus mean or sigma is going to be negative phi inverse of 0.175, which you cannot calculate. So you do 1 minus that. So this is going to be negative. When you do 1 minus 0.75, 175 is going to be phi inverse of 0.825. So 7.7 minus mean over sigma is going to be negative 0.935. That's the z-score. And the equation is going to be then mean minus 0.935 sigma. Let's solve these two equations simultaneously. You would get then, if you solve them simultaneously, 8.8 equal to mu plus 0.674 sigma, 7.7 equal to mu minus 0.935 sigma. You subtract them, that gives you 1.1 equal to 1.609 sigma, which works out sigma to be 0.864, and hence mean is 8.34, I guess. Right? Let's look at the last part over here. The lengths in centimeters of middle fingers of women in Sonland have normal distribution with mean 7.9 and standard deviation 0.44. A random sample of 5 women from Sonland is chosen. Find the probability that exactly 3 of these women have middle fingers shorter than 8.2. So first of all, there are too many things happening over here. So we are choosing exactly 3 women out of 5, and they should have a middle finger which is shorter than 8.2 centimeters. Yeah. So first we need to know what is the probability of women who have middle finger shorter than 8.2 centimeters. So let's calculate that. Probability of x less than 8.2. Yeah. So this is going to be z-score less than 8.2 minus the mean is 7.9 divided by standard deviation, which is 0.44. This works out to give us the z-score to be 0.682. And if you read the table, this is 0.524. Now, we have 5 women. So this is now binomially distributed with 5 women. N is 5. And the probability of success, that means having the middle finger shorter than 8.2, is 0.7524. So we need to choose exactly 3 women. So probability of x equal to 3 is going to be from 5 women, you choose 3 women. So 5 choose 3 times 0.7524 to the power of 3. I'm applying the formula of the binomial distribution. NCR P to the power of R times Q to the power of N minus R. So I obtained this number by doing 1 minus 0.7524. So this works out to be 0.261. Alright then, that was today's tutorial looking at extremely difficult questions on normal distribution. If you have enjoyed this tutorial, and I hope that it has cleared some of your doubts, make sure to like and subscribe my channel, and see you in the next tutorial. Thank you for watching.